So here I'm going to show you how to calculate Cronbach's alpha with Excel. I'm only going to have one video for this. If you're using Mac or Google Sheets, you should refresh your memory on how to use the tool pack to get correlations. So that might be the only thing that's slightly different here. So if you don't have the tool pack on your computer, I would advise using Google Sheets. And if you're having trouble using the tool pack to get the correlations, you should go back to a previous video in the bivariate statistics phase. So that's just a warning here. But if you know how to use the data analysis toolpack to get correlations, this won't be that hard. So here I have my items, and you want to make sure you have the individual items and you have reverse scored any that are in the opposite wording. So if you haven't done this already, please see my previous video. So I already done that, and then I want to go to the data analysis and choose correlation and press OK. And then I'm going to press here, and then I'm going to highlight all my items but not the composite score, so only your items, the individual items. Then go back over here, press that. Group by columns is fine. Make sure you have labels in first row because we have names for each item. And then I'm going to keep it in a new worksheet, and I would advise you to do that as well. We'll keep things easier for us. And press OK. Then wait a little bit, and voila, we have our table of inter-item correlations. So this is your table of inter-item correlations. If you see negative correlations, that's not good. And if that happens, it's probably because you didn't reverse code an item that you should have. So if you see negatives here, just make sure you have reverse coded everything. Okay? So there shouldn't be any negatives. And so you have all your correlations here. Notice we have ones here because if you correlate an item with itself, it's going to have a perfect correlation. So we have 1. And then above what's called the diagonal, so where these ones are is what's called the diagonal. There's no correlations above the diagonal, and that's because these would be repeats. So here is the correlation between item 1 and 2, and this would be the correlation between 2 and 1, and that's the exact same thing. So we don't want to repeat correlations over again. So above here would be just repeats, and we don't want to have repeats. So we just leave them blank. So now I need to get the average inter-item correlation. So we're going to put equals here. And then type in average. And then open your parentheses. And you're going to have to do this a little tricky. Well, it's not that bad. So I'm just going to highlight the first ones here. Don't get the 1 though. Okay. And then a comma. And then highlight the second row. You can't do it all at once. You have to put commas in between. But it doesn't take that long. Okay, then another comma. And it's just, we're going to highlight all the correlations, leaving out the ones and anything else. So we just want the correlations, which should all be positive. And so I keep doing this. It'll probably be quicker for your homework because there's less items. Okay. And then once you get to the end, you close your parentheses and press enter. So now we have an average of all these correlations. All right, so we need that. And then we need to remember what the formula was for Cronbach's alpha. And so here it is, I have it. And I'm going to work on the top first. And you can do this in your calculator if you want, but I'm just going to show you in Excel. Why not? So I'm going to do the top portion first. So we're going to have K. What is K? K is the number of items you have. In my case, I have 10. But for your homework, it will be different. And then I'm going to do Shift 8, which gives you the little star, and that means multiply in Excel. And then I'm just going to click here, because that's the mean of the inter-item correlations. So 10 times 0.3358 is 3.358097. And then I'm going to work on the bottom portion here, but I am going to do it kind of, well, you can just do it all at once. So we can do 1 plus the mean, then do the star again, so Shift 8 to get the star, and then we're going to multiply that by 10 minus 1. So the number of items you have, for your case it might be different. 10 minus 1. Make sure you put this in parentheses, or it won't do it right. So we get 3.35, and then the bottom is 4.0. And now we want to get Cronbach's alpha. So Cronbach. I'm just gonna type that there, and then I'm going to equals, and I'm going to do this because this is the top part of the equation divided by the bottom, and press enter, and we get 0.834. And this is a prediction about what the retest reliability would be if we did it. So in this case, we only gave the test one time. We only gave our scale items one time. And we found the inter-item correlations, we found the average of those, and then with Cronbach's amazing formula, we got a prediction of what the retest reliability would be. So that means if those people took the test twice and we correlated their composite scores. So that's what it means. This is a prediction about what the retest reliability would be, but it's not the actual retest reliability, just a prediction about it. Okay, based on the internal consistency of the items. So here I have a little reminder. So in a different study, the retest reliability for the Rosenberg self-esteem scale after a 2-week period is 0.85, and after 7 months it's 0.63. So they actually, in these cases, gave the test once, got a composite score off of that time period, then gave the scale again after a certain period of time and got a composite score for that, and then correlated those two composite scores together. They had the same people at both time points, and then they got these correlations. And our prediction of 0.83 based on Cronbach's alpha is actually pretty close to the 2-week retest reliability. I mean, it doesn't really get at the 7 months because I guess some people's self-esteem kind of changed over time, but it's pretty accurate. So this prediction using Cronbach's alpha about the retest reliability is pretty accurate, at least for this scale. This might not always be so accurate, but in this case it was.